Alright, this is hazard analysis, the sixth hazard analysis we're going to do. We're going to start with the previous one, LHA5, and because I didn't completely finish that, there was information that we had for a focusing lens. And I want to tie this analysis together with the next one because they're really both dealing with lens-on-laser calculations. The rest of this we sort of understand pretty much on how to input everything in terms of wavelength, energy, power, rep rate, exposure duration, beam information. So let's look at the lens-on-laser. We were given the information of a 203 millimeter focal length lens. That means it's going to take the input beam, whatever beam is right at the lens, and focus it to as small of a spot that it can to give us a high enough irradiance so that we can cut metal or drill or sketch or scribe, whatever our application happens to be. We're not given the input beam diameter information, and if you're not, just assume the beam diameter that you're using for the intrabeam. So we put 5 millimeters in. Quarter of a meter is sort of a standard default for an observer range, and for this we find out for a given focal length lens of 203 millimeters, we have an OD at observer range of a quarter of a meter away of 3.6 and about a 29 meter NOHD. That makes sense. It should be considerably less than the NOHD for the beam, since going through the focus we get a much higher diverging beam beyond that focus, and that's what the lens-on-laser NOHD is. It is the distance beyond the focal point of the lens that the beam is still a hazard. Right? And so kind of have an understanding of lens-on-laser here. So when we have that information in almost any industrial system, you'll have this type of calculation in your hazard analysis that you'll be saving in your file. Let's go ahead and look at hazard analysis number 6. So we'll load record number 7 by highlighting it, add-ins, menu, load parameters from PDB record. Again, this is a CO2 laser, 10.6 microns, continuous wave, 20 watt. And here's the lens-on laser information we have for it. It's a focal length of 127 millimeters. It has a 4 millimeter beam diameter. Now remember, this is a CO2, so the limiting aperture has changed to 3.5 millimeters. It's gotten smaller. For the intrabeam, we see we have about a 64.5 meter NOHD. Lens-on-laser, 7.7. That makes sense. They should be considerably different since you have a much lower divergence generally in the intrabeam than you do lens-on-laser. Again, that greater divergence is created by going through a focal point. And the shorter the focal point, the higher divergence you'll have. For this, we have put in a 1 meter observer range, and we see that our OD requirement is 1.7. Right? Instead of getting closer to the 3.3, which is your worst case. Of course, if we change this to 0, we should see very similar to our worst case. Our default, 2.5, see about 2.8. That's really all there is to a lens-on-laser calculation for industrial lasers. Just put the focal length of the lens in, use intrabeam diameters if you're not given something different, and then that will give you, and use the quarter of a meter, generally OD requirement being a quarter of a meter away. This is sort of a default for that. Okay, so we'll move on to the next one.